Assalamualaikum students. I hope you are doing well. I'm your maths teacher, Miss Aisha Haroon. Today we are going to learn about HCF. Let's recall the concept of factors. So what are factors? Factors are the numbers multiplied together to get another number. Factors are the numbers multiplied together to get another number. For example, in example number 1, 2 is multiplied by 3 to get 6. Therefore, 2 and 3 are the factors of 6. Because 2 and 3 are the numbers which we are multiplying together to get 6. In the same way, in example number 2, if we multiply 7 and 5, we get 35. Therefore, 7 and 5 here are the factors of 35 because their product is 35. As we are just recalling the concept of factors and multiples, so we should need to understand that what is the difference between factors and multiples. So what are the multiples? A multiple of a number is the product of that number with any other number. So a multiple of a number is the product of that number with any other number. For example, if we multiply 2 by any number, let's consider 3, the answer is 6, right? When we multiply 2 by 3, we get 6. In this case, the multiple of 2 is 6 because multiple of 2 is the product of 2 with any other number, and that another number is 3, right? So whenever we want to find out the multiple of some number, we multiply that number with any other number to get its multiple. Therefore, the multiple of 2 here is 6. In the same way, multiple of 3 is 6 because when 3 is multiplied with any other number, which over here is 2, we are getting the multiple of 3, right? So whenever we want to find out the multiple of a number, we simply multiply that number with any other number to get its multiples. In example number 2, if we want to find out the multiple of 7, we need to multiply 7 with any other number to get its multiple. So here we are multiplying 7 by 5 to get 35. So 35 is actually the multiple of 7 because 7 is multiplied by 5 to get 35, right? In the same way as the product of 5 and 7 is 35, therefore we can say that 35 is a multiple of 5 as well because 5 is multiplied by some number and then we are getting 35. I hope you have understood the concept of multiples and factors. Let's repeat the definition of multiple. A multiple of a number is the product of that number with any other number. Now let's move to the topic, and our today's topic is HCF, highest common factor. Let's learn the definition of highest common factor so that we know that what is it. So HCF is the largest common factor among the two or more given set of numbers. What is HCF? HCF is the largest common factor among the two or more given set of numbers. So when we are given with the numbers, then we need to find out that which is the largest common factor of those numbers, right? And that will be our HCF. The methods which we use for HCF are, first one is prime factorization method and the second one is division method. But today we are going to find out HCF using prime factorization. HCF by prime factorization method. There are certain steps to follow for finding HCF by prime factorization method. Step number 1 is find the prime factors of given set of numbers. So when you are given with a set of numbers, what you need to do, you are going to find out the prime factors of each of those numbers. And what are the prime factors? Those factors which are the prime numbers. Let's recall the concept of prime numbers. The numbers which have only two factors are called prime numbers. The numbers which have only two factors are called prime numbers. And what are those two factors? Yes, 1 and the number itself. Some of the prime numbers are given over here. 2, 3, 5, 7, 11, 13, and so on. Now let's move to the step number 2. Identify the common prime factors of the given set of numbers. After step 1, we are going to identify that which prime factors are common among the given set of numbers. Step number 3 is take the product of common prime factors. Take the product of common prime factors. So this is the last step and it will give us the result, which means that HCF is the product of common prime factors of the given set of numbers. So we can say that HCF is the product of only common prime factors of the given set of numbers. What is HCF? HCF is the product of only common prime factors of the given set of numbers. Now we are going to learn about the formula to use for finding HCF by prime factorization method. So what is the formula? Formula is that HCF is equals to product of common factors. HCF is equals to product of common factors. Students, now please take out your math book. We will solve exercise 2b, which is there on page number 35. Question number 4 is find HCF by prime factorization method. And part A is 64, 148, 60. So here we are given with three different numbers. And by using the steps which were given in prime factorization method, we can solve our question. First step was find the prime factors of the given set of numbers. So firstly, we will find out the prime factors for 64. As 4 at ones place is an even number, therefore 64 is an even number. And as we have to start with the smallest possible prime number, so we will see whether the given number is even or not. Because if it is even, then it is divisible by 2. And you know it that 2 is the smallest prime number. So 64 is even, therefore we will divide it by 2. 2 times 3 is 6 and 2 times 2 is 4. Now we have got 32. Again, 2 at ones place is even. The digit which is there at ones place is even. Therefore, the complete number is even and hence it is divisible by 2. So we can again divide it by 2. 2 times 1 is 2. So here we are having 3, right? And we can go for 2 times 1 is 2 because 2 times 2 is 4, which will be greater than 3. So here 2 times 1 is 2, so 3 minus 2 will give us 1 because 1 is the remainder over here. Therefore, 1 and 2 will together become a number which is 12. So 2 times 6 is 12. Now again, at ones place we are having an even number, an even digit, therefore the complete number is even. So it is divisible by 2. So 2 times, yes, 1 is now smaller number, so we will consider both the digits, right? 1 and 6 together. So it becomes 16. So 2 times is 16. Now an even number again. So it is divisible by 2. Yes. So we will divide it by 2. 2 times 4 is 8. Again an even number. Again it is divisible by 2. 2 times 2 is 4. And now 2 is divisible by 2, yes. So 2 times 1 is 2. As we have found the prime factors of 64, now we will find out the prime factors of 148. 8 at ones place shows us that the complete number is even. Therefore, we can divide it by 2, which is the smallest prime number. So, we can write 2 over here like this. 1 is smaller than 2, therefore we will consider first 2 digits. So 1 and 4 becomes 14. So 2 times 7 is 14. And next digit is 8. So 2 times 4 is 8. Now we have got the numbers, which is 74. Again, 4 at ones place shows us that the complete number is even. Therefore, we can divide it by 2 again. 2 times 3 is 6. So 1 is the remainder over here and 1 and 4 become a complete number, which is 14. So 2 times 7 is 14. 37 itself is a prime number and prime numbers have only 2 factors, right? 1 and the number itself. Therefore, we can divide 37 by itself. So 37 times 1 is 37. Now we will find out the prime factors of 60. Okay. 0 at one's place shows that the complete number is even. So we will divide it by 2. 2 times 3 is 6 and 2 times 0 is 0. Again 0 is there at one's place, which shows us that 30 is an even number and we can divide it by completely divided by 2. 2 times 1 is 2. So what is the remainder? 1 and 0 over here become 10. So 2 times 5 is 10. Now 15 is not an even number, right? Therefore, we will move towards the next prime number. So after 2, we have 3 as a prime number. Is this 15 divisible by 3? Yes, it is divisible by 3. So we can simply divide it by 3 like this. 3 times 5 is 15. Also, if you don't know whether the given number is divisible by 3 or not, we can simply use the divisibility test of 3, which was take the sum of the digits of the given number. So over here it was 15, so 1 plus 5 will give you 6. And as we know that 6 is the number which is divisible by 3, therefore the given number is divisible by 3. That is why 3 times 5 is 15. Now we've got the number 5. 5 is not divisible by 3, right? Therefore, we'll move to the next prime number, which is 5. So 5 times 1 is 5. So now we are done with the first step, where we were supposed to find out the prime factors of the given set of numbers. Now let's consider step number 2. In step number 2, we were supposed to identify the common prime factors among the given set of numbers. Firstly, we will write down the prime factors of 64. Let's have a look at this. So, how many times 2 is written over here? 2, 1, 2, 3, 4, 5, 6. It means 2 is to be multiplied by itself and written over here like this. 2 multiplied by 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 2. In the same way, we will write down the prime factors of 148. Please have a look. Okay, the prime factors of 148 are 2 multiplied by 2 multiplied by 37. Now we will write down the prime factors of 60. So 2 multiplied by 2 multiplied by 3 multiplied by 5. Now we are going to identify, we are going to loop the common prime factors. So the common prime factors among these three set of numbers are, first is 2, this is common, and the other one is again 2. No other factor is common among the given set of 3 numbers. Now we can write down the common factors. So the common factors are 2 and 2. Now let's move to the third step. What was the third step? the third step was to take the product of common factors. So now we'll use the formula HCF is equals to product of common factors. So we can write that HCF is equals to 2 multiplied by 2. And 2 times 2 is 4. Therefore, the HCF we have got is 4. We have already solved part A. Now let's solve part D. In part D, we are given again with 3 different numbers: 27, 130, 46. We will follow the steps of prime factorization method to find out the HCF. Step number 1 was to find out the prime factors of the given set of numbers. So let's find out the prime factors of 27. 7 at one's column shows that the given number is not an even number. Therefore, 27 is not divisible by 2. So we will move towards the next prime number, which is 3. For 3, we always use the test of divisibility, which is we check whether the given number is divisible by 3 or not. So we are going to simply add the digits of the given number. So 2 plus 7 is 9. As 9 is a multiple of 3, or we can say as 9 is completely divisible by 3, therefore 27 is also divisible by 3. So we will divide it by 3. As the first digit, which is 2, is smaller than 3, therefore we will consider both the digits as a complete number. So it is 27. 3 times 9 is 27. The next number which we are supposed to divide is 9. And we know that 3 times 3 is 9. And now we have got 3. So 3 times 1 is 3. Now we will find out the prime factors of 130. The 0 at one's place shows that the complete number is even. Therefore, we can simply divide it by 2. So 2 times, now the first digit is 1. Therefore, we will consider first 2 digits together. Why? Because the first digit alone is smaller than 2. Therefore, we will consider first 2 digits together. So it becomes 13. 2 times 6 is 12. 1 left. So that 1 and the 0. Together they become 10. So 2 times 5 is 10. Now 65. As we can see that the 5 at one's place shows that it is not an even number. Therefore, it is not divisible by 2. Let's move to the next prime number, which is 3. So is it divisible by 3? Let's check it. You will simply add the digits of the given number. 6 plus 5 is 11. And 11 is not a multiple of 3, right? 11 is not completely divisible by 3. Therefore, 65 is not divisible by 3. Now let's move to the next prime number, which is 5. Is it divisible by 5? Yes. Why? Because if we have 0 or 5 at one's place, it means that the given number is divisible by 5. So 5 times 1 is 5. 1 will be left over here. So that 1 and this 5 will become 15. So 5 times 3 is 15. Now the number we have got is 13. 13 is itself a prime number. Therefore, it is not divisible by any other number, right? Because it has only two factors, 1 and the number itself, which is 13 over here. So we will divide it by 13. 13 times 1 is 13. Now let's find out the prime factors of 46. 6 at one's place shows that the complete number 46 is divisible by 2 because it is an even number. So 2 times 2 is 4 and 2 times 3 is 6. Now the number we have got is 23. 23 is itself a prime number. Therefore, we can divide 23 by itself. 23 times 1 is 23. Now let's move to step number 2. Step number 2 was to find out that which factors are common among the given set of numbers. So firstly, we will write down the prime factors of 27. Have a look at this. 3 multiplied by 3 multiplied by 3. Now we will write down the prime factors of 130. 2 multiplied by 5 multiplied by 13. And now the prime factors of 46. 2 multiplied by 23. We were supposed to loop the common prime factors, but here we can see that there is no common prime factor. But what will be the common factor then? We know that 1 is the factor of every number. So as 1 is the factor of every number, we can simply write that common factor is equals to 1. And HCF is equals to product of common factors. But here we have only one common factor, which is 1. So we can simply write down that HCF is equals to 1. Highest common factor over here is equals to 1. Students, as we have solved the two parts of question number 4, the rest of the parts you can practice by yourselves. Now we will solve question number 5 of exercise 2B on page number 35. Question number 5 is find HCF of given prime factors. So what does the question mean? It means that now we are already given with the prime factors, right? Step number 1 of prime factorization method they have already done for you. You are supposed to loop the common prime factors and then take their product to find out the HCF. Let's have a look at part A. These are the prime factors of the first unknown number. Okay, over here we don't know the numbers. They have already found the prime factors and directly given to you. The prime factors of second number and the prime factors of the third unknown number. What are we going to do? We will write them vertically like this. These are the prime factors of the first unknown number, then the prime factors of the second unknown number, and the prime factors of the third unknown number. As prime factors are already here, so we will simply loop the common prime factors. Can you find some common prime factors? Yes. 2 is common among all these three set of prime factors. Another 2 is common. Any other number which is common among these three sets? Yes, 5 is common. So the common factors are 2, 2 and 5. So what are the common factors? 2, 2 and 5. And according to the third step, we are supposed to take the product of the common prime factors to find out the HCF. So HCF is equals to product of common factors. So here we can write down that HCF is equals to 2 multiplied by 5. And as we know that 2 times 2 is 4. So we will firstly multiply the first two numbers and write the third one as it is, which is multiplied by 5. Now in the third step, we can simply multiply these two numbers together. So 4 times 5 is 20, which is the HCF. Students, we have already solved part A. Now let's solve part C. Again, we are given with the prime factors and we can simply find out the common prime factors by writing the prime factors of the first unknown number, then the prime factors of the second unknown number, and the prime factors of the third unknown number. Now we are going to loop the common prime factors. 3 is common among all of these three. Then 5 is common and another 5 is also common. So the common factors are 3, 5, and 5. Common factors are 3, 5, and 5. Now we can simply move to the third step of finding HCF by prime factorization method. So the third step was we are supposed to take the product of common factors to get the HCF. So HCF is equals to product of common factors. HCF is equals to 3 multiplied by 5 multiplied by 5. Firstly, we'll multiply the first two numbers together. 3 times 5 will give us 15. And the third number will be written as it is. So 15 multiplied by 5. I hope everyone knows the table of 15 and we can simply write the product of 15 and 5. But if you just forget the table of 15, no worries. We can simply multiply these two numbers by drawing a rougher column. So 15 times 5 is, let's multiply it. 5 times 5 is 25. So 5 will be written over here and 2 will be taken as carry. 1 times 5 is 5 and this 5 will be added to the carry. So 5 plus 2 will give us 7. 75. So the product of 15 and 5 is 75. It means that the HCF is 75. Students, I hope you have understood the concept well and you can do the rest of the parts of question number 5 by yourself. Take care, students. Thank you. Allah Hafiz.